Hello everyone, my name is Dr. C.S. Raghuvanshi. I am Professor, Department of Computer Science, FET Rama University, and today's topic of discussion is software engineering. So before starting the subject, we will look at the outlines of today's lecture. The outlines are: first we will discuss about science and engineering, what are the differences between the science and engineering. Then we will look software and software engineering. Then we will discuss about software development approaches like traditional approach and the engineering approach of software development. Then we discuss about software crisis, reasons of software failures, and when do we call software application successful. And finally we will discuss about what are the reasons why we are learning this subject, that is software engineering. So let's start. First, you should clear about what is the difference between the science and engineering, because most of the students who are pursuing computer science and engineering suppose that science and engineering both are same, but both are not same. There is a difference between science and engineering. So the science represents the body of knowledge that deals with physical and the natural worlds, while engineering is an approach that deals with the solution, or we can say it provides the solution to the problems. So the goal of science and engineering are different. The science is subject to discuss and describe the natural world, and it starts with arising the questions, and after arising the questions, science formulates some hypothesis and test these hypotheses by performing some test, and result be the principle, and these principles are known as scientific principle, or you can say scientific methods. While engineering starts with formulating the problems, and after formulating the problem it makes some constraint and define the solution to the solution of the problem, and the ultimate goal of engineering is to uplift the living status of the human beings. So these are the some differences between the science and engineering. So in its simple word you can understand, science is an approach that describe and understand the physical and the natural world, while engineering deal with the solution to the problem and try to make the human life better in all sense. Now come to the discussion about the software and software engineering. When we talk about the software, we think that we are talking about something computer programs. It is real. Software is a computer program that are designed to perform a specific task. But when we talk about the software, it ranges from very small kind of software to a large kind of software. The small kind of software, for example, the calculator. We can perform many arithmetic operations by using computer application, computer program, and it may range to very large kind of software also. For example, the railway reservation is a very big software that are used for getting the railway reservation and taking the result and knowing the information about the train schedule. These are the things, and it may range from single user application to a multi-user application. Single user application means these are the software that can be used by a single people or single user at a time. But there are some many examples where more than one user can operate at the same time on the computer programs, or it can be used by multiple users. Same, the railway reservation is an example of multi-user application, because more than one user can access the application at the same time from their different location also. And the software may range from very personal application to the business application. For example, we are using MS Word, MS Excel for our personal use. For example, I want to take some printout and I want to draft some letter. That time I will use MS Word. I want to make some mark sheet. That time I will use the MS Excel. I want to make some presentation. That time I will use MS PowerPoint. But in some other sense, suppose we are working in a company and we want to do some accounting on the computer. That time I will use some enterprise-wide application that cover all the aspect of the business. That is, these software are known as ERP, Enterprise Resource Planning Softwares. So you can easily range software from very simple kind of software to the complex kind of software, single user software to multi-user software, personal software to company or the business oriented software. So these are the ranges of the software. Now come to the point, software engineering. So software engineering is nothing, it is an engineering approach to develop, operate and maintain the software application. So now you can easily understand what is software engineering. Software engineering nothing more than the engineering approach for developing the software. So now come to the point, the definition of the software engineering given by the IEEE, and IEEE is saying the software engineering is an application of systematic, disciplined, quantifiable approach to the development, operation and maintenance of software. That is the application of engineering to software. So according to IEEE, software engineering is an application of what? Systematic, disciplined and quantifiable approach to the development, operation and maintenance of the software. Means the software engineering not limited to the development of the software only. It is involved in development as well as in the operation of software and as well as in the maintenance of the software throughout the software life. So we can say software engineering is not only involved in development, but it is also involved in the operation and maintenance of the software. Now come to the next point of discussion, that is software development approach. Yeah, there are various kind of approach are for developing the software, but these are the two basic approach, that is known as traditional approach and the engineering approach. The traditional approach is also known as exploratory approach or fix and build kind of approach. Suppose we want to make a software, very small kind of software, that time the traditional approach is good enough, because after getting the information, after getting the requirement of the user, I can start typing the code, I can start coding the program. So this kind of approach is not suitable for the large kind of project. Suppose I want to make a project for the university automation. That time it is not feasible that after getting the information I just start typing the program. It is not good for large kind of program, but it is good enough for a small kind of program. Suppose I want to make a program for arithmetic calculation, I want to make a program for library automation system, suppose I want to make a program for office automation. So these kind of small application can be easily developed by using the traditional approach, but traditional approach is not good for large kind of software. So what problem may arise if we are adopting the traditional approach for large applications? So then this we will discuss in later. So the another approach is engineering approach, means we are following the systematic, discipline and quantifiable approach to the development of the software, and this approach is known as engineering approach. Getting my point? So now come to the another point of today's lecture, that is software crisis. What do you mean by software crisis? Yeah, I am telling you one fact. More than 98% software are failed after developing the application. What are the reasons behind more than 90% software are not in functioning? What are the reasons? Means only 2% software are usable and are using. 98% software are failed. Just because of that, we are not adopting the right approach of software development, because we are after getting the information, we start typing the code, and after completing the coding, we will start implementing the project. And these are the reasons why 98% software are not successful. So this is the huge percentage, that more than 98% or only 2% software are successful. So this fact is known as software crisis. Suppose one person is developing the software and 98% of his development is not get successful. So this scenario, this phenomena is called software crisis, and are trying to make some approach so that this percentage can be improved. We want to improve it up to 50%, means minimum 50% of the software must be successful. And for getting the success, for increasing this ratio, we should adopt the right approach of software development, and this right approach of software development is known as software engineering, or you can say engineering approach for software development. Getting my point? Now come to the point, that is reasons of software development, software failure, sorry. The main reason of software failure is not adopting the right approach of development, because most of the people want to develop the software in a day, in a month, or in a year only, but in really software development take much more time than to 1 day, 2 day, or 1 year. So what you should do, you should have sufficient time, and you should follow the right approach of software development. This is the basic reason behind the software failures. The another reason is not getting the user information. Many of the software developer take the information from the user and don't analyze, don't understand the real need of software, real need of users, and just because of that most of the software are fail. After completing the software, user rejects the software. He doesn't accept because his requirement is not fulfilling by the software. That's why many of the software are not successful or not implemented at the client side. So these are the two reasons: not adopting the right approach of development and not getting the accurate and the right requirement of the user. These are the two basic reasons behind the software failures. Now come to the point, that when do we call software application as a successful? This is right. So the question is that 98% software are fail and only 2% software are successful. So when do we call one application as a successful or as a fail application? The reason, when this application is satisfying all the requirements of the user, and user are accepting that application for implementing at the client side, then only we say the software application is successful. And this is not only the one parameter to call the software application as successful. If user is accepting, user is allow us to implement at the client side. The another parameter also we should discuss. The another parameter, it must be usable. After implementing at the client side, it must be usable and it must be used for a long time, and only then we will say the software application is successful. Now come to the point, why we are learning this subject. This subject means software engineering. The reason is clear. The ultimate reason, the ultimate goal of learning this subject is to reduce the chances of software failure, because the software crisis is huge. 98% software are not getting success. 98% softwares are not we call as successful software, and we want to reduce this percentage of failures, and we want to improve the percentage of success. That's why we want to learn this subject, so that we can understand the right approach of learning, of developing, operation and maintaining the software. So this is all about today's lecture. Thank you very much.